No, that's not more water. Fill the walls of water up to the height.
Soil is a living organism. Soil health is very important if you want to grow nutritious, healthy, and tasty crops. Think of soil as the loose material that covers the Earth's surface. It's like a living skin of organic material that provides nutrients to plants. In addition, the plants provide food for people and animals that live on the Earth. Soil contains all kinds of organic matter and numerous species of living organisms. Soil is made from rocks, decayed plants and animals, air, and water. Soil is the natural foundation for life on Earth. Big rocks break down into smaller and smaller pieces that eventually become part of soil, but in a different texture. This process takes hundreds of years to yield several kinds of textures. There are four main soil textures that everyone on Earth deals with: rocks, clay, sand, and silt. Let's get to know your soil. Sand is loose grains of worn or disintegrated rock. It feels rough and gritty and has air spaces between the grains of sand to let water drain quickly. In the White Mountains, we use cinder sand, remnants of volcanic activity from millions of years ago. Silt is made of much finer grains of sand and feels smooth when wet. Clay has the smallest particles and feels sticky and slick when wet, and becomes very hard when it dries. The particles are fine enough to hold water, hence, clay was used to make pottery as well as adobe bricks for housing. Clay pottery has been utilized by all cultures across the world. Loam is the best type of soil because it combines percentages of sand, clay, and silt to make the ideal planting soil. There is a fourth element to add, and that's humus. Humus is made from decayed plants and animals that break down over time and add nutrients to the soil to make a very successful growing medium. It's not just dirt. Okay, it's dirt. But once you amend the dirt and get the pH corrected along with the macronutrients such as nitrogen, phosphorus, and potassium, it becomes soil. Once you have an idea of what soil textures you're dealing with, it's easier to figure out what seeds will work best in your garden. In order to get to know your soil, test it for textures.
It has a lot of debris in it, so we're going to try to sift a little bit of this out. We're going to put this in the jar, and then we're going to add water. And when you're testing your soil for alkalinity, which is pH, whether it's alkaline or acid, most tap water is alkaline, so you want to use, if possible, distilled water. This isn't quite distilled water, but it's not tap water. And you want to fill that up. And we're going to fill it up as much as we have water in the bottle of water. And we're going to shake it. For preferably up to 48 hours, you don't want to move it, and the soil will layer out pretty well. Okay. And it's sort of a muddy mess right now, which is why you want to let it sit for a couple of days to let the silt, the sand, and the clay layer out. Okay, so we've done our mason jar tests on 2 soil samples. Our first soil sample I'm going to show you is from the White Mountain Community Garden. We've been here for 11 years and we've been working the soil for that many years, and we have a very atypical soil sample here to show you. So what we've got is, you can see here, there's two different layers. You've got this down in through here, and then you've got this little layer here. And we're not quite sure what the makeup of this is, but we know that we don't have any clay in it. This came out of one of our garden beds that we've been working for a long time. This sample here is out of somebody's personal garden. We do have 3 distinct layers, and soil is made up of sand, silt, and clay. And these are just organic amendments that somebody's put in there, called humus. Humus, not hummus. So here we have approximately 2 inches from the bottom of the jar to this top layer here. And we have approximately 1.5 inches here, 1/4 of an inch, and 1/4 of an inch. And this is 75% sand and 12.5% each of silt and clay.
Now that we've measured the different sediments in the soil sample, we need to learn how to read the soil texture triangle to understand what kind of texture this soil sample has. The left side shows percent clay. The right side shows percent silt. The bottom shows percent sand. Take a look at the percent clay. Notice the numbers increase as you go up the triangle, and you follow the lines straight across. Look at the percent of silt. Those numbers are on a diagonal sloping down, and notice when we follow a line, it goes downward on a slope. And if you follow along the bottom and you're looking at the percent sand, the numbers are also slanted. This time they're slanted up. So whenever we look at a number, we follow those slanted declines. Here's the example of our measurements. Clay is 12.5%. 12.5 is toward the bottom of the triangle between the 10 and 20. Follow the line straight across. Silt is also 12.5%. Follow the silt line down to the bottom of the triangle. The percentage of sand is 75. Follow that line from the bottom of the triangle up. Notice that the lines intersect in sandy loam. Sandy loam offers good drainage, but the soil sample needs more silt and a little more clay. Ideal loam includes 20% clay, 40% silt, and 40% sand. Now that you know how to determine the textures of your soil, you can balance and amend it.
soil testing. And you need to dig down about, 3 to 4 inches. And I'm just going to go with 1/4 of a cup. And then put the lid on and shake it really well. And this really needs to sit several hours or overnight is best. This is the same soil that's actually been sitting for several hours. We're going to test from the water in here, trying not to get the soil mixed with it. First, let's just do the pH from the regular soil that we pulled out of the same area. So that's probably good. Because tap water is shown to have alkaline, we're going to use distilled water for this test. So we're going to fill this little compartment with the distilled water up to the fill line, which is almost there. Good. Then we're going to cap it because we're going to shake it really well. And for this pH test, it takes only a minute to really get some results. So we're just going to let this set for about a minute. And then we'll read the results. Meanwhile, we're going to start filling the other compartments to test for nitrogen, phosphorus, and potassium. These take 10 minutes to sit once we get them mixed. And we're going to use the liquid, the water liquid from the soil that we mixed with the distilled water. And we do fill both sides of the compartment for this one. We filled up to the fill line, so we're going to the other side. Almost there. That looks good. Cap it securely and shake. Looks good. And again, these have to set 10 minutes. So I'm going to start the timer for 10 minutes and we'll continue filling the other compartments. This is the nitrogen. Cap it and shake. Looks good. And this is the phosphorus. Good. So those will remain. The timer goes off, we know those are ready. Let's look at the pH. Look at the pH. Okay, we're going to compare the left side to the colors over here on the right to see which one matches closely, the closest. And I would say it's almost neutral. Doesn't look like any of these.
No.
So we know it's not acidic. Neutral to alkaline. That's the pH. Okay. I think it's probably deficient. That's how I read that. Big difference. Oh my goodness. I would say this is depleted.
Okay, so now you know how the soil is tested out of that garden.
Yes, out of the berm.
Okay, out of the berm. So what are you going to do?
Okay, we know it's deficient in nitrogen. We know the pH is okay. And it's also somewhat deficient in phosphorus. So we're going to add some blood meal and some bone meal.
Okay.
And we will read the directions on the packages and get the correct amount, not to overdo it, but that should take care of our problem.
Cinder sand and want to have peat moss. Because I'm starting the seeds, I want it fine. So I made this screen up to filter my peat moss, because you get several large pieces in the peat moss, and I mix it 50-50. Keep it pretty moist. Then I got these trays a few years ago. Unfortunately, they don't make them anymore. And I use these for my seed starts anymore. And then I made this little form up, so then I can put it in here and press it down. And then here I've got some devil's ear lettuce seed. And then I'll just sprinkle it. A little heavy in each row. I'll skip a row because I may want to plant something else in there. And I just have to watch real careful that we don't sprinkle seeds over in the other row. Then I'll just take a little soil just to cover the seeds. Sprinkle that over the top. And this is the crumbles. So you can sprinkle that on till you get everything nice and dusted up. 1/2 ounce of that. The earth nectar. And then I just pour this in the bottom. You can use just a liquid fertilizer for houseplants. It will soak up into my soil mixture, and so I've got all the nutrients in the soil for when the plants start growing. And when I replant them into the 6-packs, I will do the mixture again with the liquid ambrosia and the nectar. And I won't fertilize them again until I plant them out in the garden. Tomato plants will be running about 2 months before I move them out. And then I'll use fish emulsion. And I've got a new product to try this year. It's supposed to be real good. And it has a B1 in it. It takes about 30 days. Then I can start cutting the lettuce and have nice fresh salads. Spinach is a cool weather crop. If I would start it right now in here, I would not put the heat mat underneath the tray, because by my high-low thermometer, the low was 55, which is an excellent germination temperature, and the high was a 72 in my room. If you're on a budget and you can't afford to buy everything else, you just take an egg carton, you can put your starting soil in this and put a couple of seeds in each container. Then you can set this in water to where it'll soak up the water, always water from the bottom. You can use these for starting seeds because it has the holes in the bottoms. So you put your mix in there and make some little furrows or sprinkle some seeds in there. And you got an automatic dome that you can use for a couple of days, and then open it up and keep this in a small dish and water from the bottom. And these are excellent seed starters. I will use white lightning on them. Concentrated mycorrhiza only takes a little sprinkle, which is mycorrhiza.
You may have heard the term mycorrhizal fungi, sometimes called mycos, in recent years, but what exactly are they? The origins of the word offer the simplest explanation. Myco comes from the Latin word for fungus, and rhiza is Greek for root. These fungus roots can be greatly beneficial to gardeners. Mycorrhizal fungi belong to the same group as mushrooms, the fungus kingdom. A mushroom is similar to an apple. It is the fruiting body of a larger organism. But, rather than growing from a tree, the mushroom is formed from an interconnected network of root-like tubes called hyphae. Most hyphae are very small, between 1/10 to 1/50th of the width of a human hair, making many of them invisible to the human eye. More than 450 million years ago, certain types of plants and fungi formed a symbiotic, or mutually beneficial, relationship with each other. The plants give the fungi sugars that they produce through photosynthesis. In exchange, the fungi give the plants nutrients and water that they extract from the soil. 80 to 95% of land plants benefit from some type of mycorrhizal relationship. What does this mean for gardeners? Let's say you plant a seed in soil without any mycorrhizal fungi. The plant's roots will go out in search of nutrients and water to feed its growth. As the available resources are used up in one area, the roots grow further and further out, expending more and more of the plant's energy. Now, let's introduce some mycorrhizal spores. The plant sends signals out to any mycorrhizal fungi in the area, and the spores respond by growing hyphae in the direction of the signal. If a spore is able to find the root of the plant, the hyphae will penetrate the root and begin to grow structures that allow for the plant and the fungi to exchange resources. The mycorrhizal fungi will now begin to grow an extensive cotton ball-like mass that will give the plant access not only to the nutrients and water outside the reach of its roots, but, since the hyphae are so small, they can access nutrients in the small spaces between the roots as well. Though most commonly grown plants will benefit from mycorrhizal applications, there are a few exceptions. The Brassica family, which includes plants such as broccoli, cabbage, radishes, and kale, is one. Beets, chard, blueberries, cranberries, and rhododendron are some others. Though mycorrhizal fungi are naturally occurring in most soils, the application of fungicides and pesticides, the use of heavy machinery, and leaving soils without any plant growth for weeks at a time have created soils with little or no mycorrhizal fungi populations. The ground surrounding newly built residential neighborhoods and commercial properties is particularly lacking. Only in recent years have commercial mixes become available to reintroduce these important organisms back into garden soils.